Hi, welcome to lesson 4.4, Congruence and Transformations. Now, in this lesson, we're going to be using everything that we have learned about transformations. Okay, so far we have learned about translations, rotations, and reflections. By the way, if you hear any screaming behind me, nobody's getting murdered. Just my son is taking a bath and making a lot of noise. The room that I'm recording in is right next to the bathroom, so there's a lot of noise coming from over there, and this microphone is very sensitive and it literally picks up everything. Okay, so we are on page 107. Now, in this lesson, you are going to need a total of 6 graph papers. Now, for the first part, just worry about gluing the graph paper. So on page 107, you are going to glue 2 pieces of graph paper with the X and Y axis through the center. We'll come back to this page in a little bit. Now turn the page to 108, and you are going to glue 2 pieces of graph paper. The first one is going to be for problem number 1. The second one is going to be for monitoring progress question number 1. In the next page, page 109, you're going to put 2 more pieces of graph paper. This one's going to be for number 2, and this one here is going to be for number 3. We are skipping quite a bit of stuff from this lesson. We're only going to do literally half of the objectives, so anything about these theorems, don't worry about them. We're not gonna use them in this lesson. All right, so let's go back to page 107. I'm gonna zoom in on this so you can see just that portion. Now, if you need to pause the video to write this down, do so, and then proceed with the video to see the examples that we're going to do. Not the examples, but the exploration. All right, what you have here is you have 3 points, A, B, and C. And they want us to do 2 transformations. They want us to do a translation followed by a rotation. So that's the first thing we're going to do. First thing I'm going to do is I'm going to plot these points. Okay, B is 2, 4. And C is -1, +2. Oh, made a mistake. Give me 1 second. I'm changing the coordinate for C because it doesn't even make a triangle. So we're going to go ahead and change that. And let's put the triangle right there. Let's do 3, 2. So if we're going to do this, it needs to at least create a triangle. All right, so you're going to connect them, and you have a triangle, triangle ABC. Okay, so we are going to do 2 things to it. The first thing we're going to do is we are going to do a translation followed by a rotation. So the translation, I can do that very easily, but I'm going to actually apply the rule first and then graph them. So I'm going to do step 1 first. So for these, I have A prime, B prime, and C prime. So I'm applying the rule first. I'm going to subtract 1 to the x and add 1 add 3 to the y. So subtract 1, 1 minus 1 is 0. 3 plus 3, that's 6. 2 minus 1, that is 1. 4 plus 3, that's 7. 3 minus 1 is 2, and 2 plus 3 is 5. So there. I have translated the diagram. Now, I'm not gonna graph it yet because I want to apply the second rule. As a matter of fact, I'm not even going to be graphing these. Okay, so now I'm going to apply the second rule. The second rule is I'm going to change my x coordinate to the y value and the y value to the x coordinate, but into its opposite. So 0, 1, 2, and all of these are going to be opposite. -6, -7, and -5. Now, the only thing that I'm going to graph is going to be these three right here. Normally I would do this one, but I want only to do this one in this case. So -6, 0, 1, 2, 3, 4, 5, 6. That is my A prime. Oh, I'm not going to have enough space. Darn it. Maybe. That's 6, -7, -1. So that's going to be B double prime. Sorry. And then C is going to be -5, 2. 1, 2, 3, 4, 5, and then up 2. Hold it. Something wrong. Oh, I figured what I'm doing wrong. Okay. C that is correct. The only one that is actually wrong is, let me see, it's my B, because it should say -7, 1, and that is not the right place. So -7 and then 1. So here is where it is. Sorry about that. Now here's the thing. I want you guys to notice that these two triangles are exactly the same size. Okay? When you do a sequence of transformations and it does not change the size of the polygon, we call that a congruence transformation. Now, it's easy when they give you a set of coordinates and ask you to do stuff to it. Like in this problem, we did a subtraction of 1 and then an addition of 3 for the y. Then after that, we did a 90-degree rotation. So we literally just translated and rotated, and boom, we got this. So we call that a congruence transformation. Now, it's harder when you have to work your way backwards. Meaning, if I give you this, now go ahead and pause the video and copy this. Okay, once you're finished copying it, you can resume the video. All right, so here's what we have. Pre-image and the double image. That means that something happened in between. I don't know what it is. We have to figure out what happened. Okay, so looking at this, you can tell that the orientation of this is not the same. So that means that there has got to be either a reflection or a rotation. Now, if you were to have reflected this over maybe the y-axis, the shape of the new figure is not going to look anything like this. So that means that there was a rotation. Now, what I suggest is use a piece of patty paper to figure this out. So that's what I'm going to do. I have a piece of patty paper, and I already traced it. I did this ahead of time. So I'm wondering, what could I have done to get this to map to this? And the nice thing about all these is that there's no more than 1 or 2. Okay, so I'm thinking, okay, what if I try a reflection? If I were to do a reflection, then I would do, it'll look something like this. I'll just flip it over and you can see that even if I translate it, it's not going to work. So reflection is out of the question. What about a rotation? Well, let me try a rotation. If I do a 90-degree rotation, it's going to look something like this. And you notice that these two figures have the same exact orientation, which means that the only way to map this onto the new one is by a translation 1, 2 units down. So what ended up happening here? We ended up having a rotation of 90 degrees and followed by a translation. Okay, and for the translation, we just ended up moving the y value by 2. Okay, now in both of these this and this, they are exactly the same size. So we say that triangle ABC is congruent to triangle A prime, B prime, and C prime. So they're congruent. Now let's go ahead and start our examples. Our examples are on page 108 and 109. Example 1. Identify any congruent figures in the coordinate plane. So take a look at it. Okay, so we can see that there are some figures that are exactly the same. We're going to go alphabetically. A, B, C, D, N, P, Q, R. Okay, so as you can see, the order of the letters are, consistent with the alphabet. So that means that in order to get this to map to this, there has to be a translation. Okay, so I'm just going to color code these, or I can just say that these two are the ones that are, similar. So this one here, not similar, shouldn't say similar, are congruent. So these two right there, they're congruent. So we can say that A, B, C, D is congruent to N, P, Q, R. Why? Because there is a translation that can map it. Okay, and the translation would be 1, 2, okay, 1, 2, 1, 2, 3, 4, 5, 6. So that's the translation that can map those two. Are those the only one? No, there's more. Okay, you can look at this triangle with this triangle. Okay, this triangle and this triangle, they happen to be congruent. So that means that there's a sequence of transformations that can map one onto the other. So EFG, KLM. So triangle EFG, EFG mapping onto triangle KLM. Well, what could happen to map this onto this? Well, you can see that there is kind of like a symmetry there. And it just so happens that it's a reflection about the x-axis. So reflection about the x-axis. Now, last but not least, you can see that those two triangles are actually congruent as well. This one and this one. Now the question is, how? How are they congruent? So we have to follow the order of the letters. Okay, H, I, and J congruent to triangle. Well, what order is it going to be? Okay, it's going to be S, T, and U. So S, T, and U. So what could map this onto this? If I were to think of a reflection, J would map onto S. And you can see that J should map onto U. So it is not a reflection. It's going to be a rotation. If we do a rotation, J will map onto U, I will map onto T, and H will map onto S, which is what we want. So we have a 180-degree rotation. And that is example number 1. Okay, monitoring progress example number 1 looks like this. Let's see what we can do. Now the easiest ones you can see here is probably this one and this one. So you have G, H, I, J. So G, H, I, and J should be congruent to this one. Okay? So if you look at that one, it should be N, P, Q, R. So the easiest thing to map this onto this will be just a simple translation. Okay, so the equation for the translation is there is no movement in the x, but there is a movement in the y, and it is 1, 2, 3, 4, 5, 6. Y minus 6. So in this case, this is congruent to that. Okay. Okay. The next one that I can see here is this one and this one. They both are exactly the same size. Okay, so we have MKL. Okay, MKL and STU. Actually, I take it back. It's KLM. Gotta know your alphabet, man. KLM. Hold on. KLM and then STU. So K has to map onto S, and L has to map onto T, and M to U. So I can see here clearly it's going to be a reflection about the y-axis. Okay, and the last one that you have here is going to be this one. This one with this one. Now, obviously, I'm very sure that this is going to be a reflection, not a reflection, but a rotation. So you have triangle ABC congruent to triangle DEF. So I'm going to use a patty paper just to make sure. Okay, so if I were to copy this down and rotate it 90 degrees, you can see that it perfectly matches it. So yes, it is going to be a 90-degree rotation, counterclockwise. Okay, so that is monitoring progress example number 1. Let's look at example number 2. Example number 2 is going to be a little bit more difficult, and for this I suggest you guys get a piece of patty paper. Okay, here's example number 2. Make sure you're copying down the graph. Now, what we want to do is we want to map this onto this. So, like I said, it's way better if you use a piece of patty paper. Okay, so what I'm going to do is I'm going to copy this, A, B, C, and D. Now here's the thing, we need to match the letters with the corresponding letters. So here A has to map onto E. So let's start with that. If I were to do maybe a rotation, okay, maybe a rotation like this, and if I follow it by a translation, you can tell that that's not necessarily going to work. Okay, so let's see what else could I do. Could I do a 180-degree rotation? I don't know. Let's try it. 1, 2. That is not going to work. Okay, so let's see what else I could do. Could I do a reflection? Well, if I reflect it across the y-axis, it's going to look something like this. And then could I do a translation? Perfectly. So you see, sometimes you just have to play with it. Okay, so what did we do? We ended up doing a reflection about the y-axis, okay, followed by a translation. Now, how much was the translation? Well, let's figure it out. After the reflection, it looked like this. And then I moved it 1, 2, 3, 4. 4 units down. So sometimes these are easy, sometimes these are not going to be easy. But the patty paper is what really, really helps. You just kind of have to play with it. Now, what you guys saw with the reflection, when you're doing a reflection and you're doing it on patty paper, all you have to do is a horizontal change like this. If you are doing a reflection about the x-axis, all you got to do is a vertical reflection like this. Okay, now look, that would also probably work, but in this case, they don't really match because the letters are not matching what they're supposed to. Okay, so that is example number 2. So we described the congruence transformation that maps this onto this. Now for our last one. Describe a congruence transformation that maps those two. So like I said, I'm going to use another piece of patty paper. And I have to map J to M. So J to M. So let me see what I can do here. Okay, so look, if I were to do a 180-degree rotation, it'll look something like this. That's 90, and that's 180. As you can see, they're not going to match. Okay, so let's start again. All right, well, what if I do a reflection? If I do a reflection about the x-axis. Okay, so there's a reflection about the x-axis. Now what I can do is a translation. 1, 2, 3, 4, 5. Okay, so you can see that it matches. All right, so what we ended up doing was a reflection about the x-axis followed by a translation. Now the translation happened to be, unless I count it right, 1, 2, 3, 4, 5. 5 units to the right. And no units up or down. Okay, so that is example number 3. Please make sure you guys are doing your extra practice. Your extra practice for section 4.4 is on, let me see. Oops, there's all these pages in here. Okay, it's on page 110 and 111. Now, because we did skip some stuff, please make sure you do not do problems 6 through 10. All right, thank you and have a great day.